In this video, we'll continue our discussion of vector fields by determining how to test for a conservative vector field. Now, so far we've only dealt with, we did one example of how to find a conservative vector field given a potential function, and it was only in two variables, right? So in two space. We're going to do three space later. I put that here. But if we have a vector field defined like this with m and n, right? M being the I component, n being the j component. There's our vector field. We can check to see if it's conservative by just taking these partials and seeing if they're equal. If they are equal, the vector field is conservative. If the vector field is conservative, we get that as well. That's what this thing means, if and only if. What that means is if it's a conservative vector field, we got this. The if and only if means if I got this, then I know the field is conservative. It works both ways. All right, so we are going to run a test doing this. Three-dimensional space will be taken care of later. It's a little more involved than just this, so I'm saving it for a later video. Now, this vector field, I'm going to go ahead and it's not completely like simplified, so I'm going to do that because it makes it much easier because I get 1 over x comma negative 1 over y. There's my vector field, and they just want us to test if it's conservative. So this is m, this is n. We're going to label those a lot throughout these next sections. And we're going to find the partial of m with respect to x. Right? Well, that's, okay, with respect to, oh, I wrote down the wrong thing. It's the partial of n. It's the other one. So it's the, like, j component with respect to x. So n is, let's go ahead and write it here just to make sure I don't lose anybody. This is with respect to x of something with only y, so it's 0. If I do m now with respect to the other variable y, this is the partial with respect to y of 1 over x, and that's also 0. Since they are both 0, so this equaling that implies that f, write that a little better. It's not much better. Let me try again. F is conservative. All right, so that's going to have properties. Right now we're just determining the definition, and then in this example we learned how to test. So if those two things are equal, we know the field is conservative. We don't even have to worry about the potential function thing. Now, to tell it's conservative, the method that we're building up to, we're going to work for that potential function. But as of right now, we don't have to find it to show that it's conservative. All I have to show is those partials are equal.